I'm excited to share with you some learning tools and resources that are going to help with some of the challenges facing secondary education. Specifically, we'll be talking about the next generation science standards, what models are, CubeSats, DemoSats, and looking at an example of how to use a DemoSat to engage students. I'm Ben Nieswender, and you can follow me at bnieswender.
Oh, and this is Chris. You can follow me at Ardusat Chaffman.
And we are part of the learning team here at Ardusat. And so we're excited to share a few things that we've learned recently and share a couple of tools. So what are the challenges facing education?
So many, myriad problems, but to pull out a few: engagement, technology gap, achievement gap, standardized science test scores.
These are all good things, and I think key among them is teachers have a difficult time with professional development, finding time to learn how to do all of these things. So adoption can be difficult, and we're also trying to figure out what do we teach students for these careers and jobs that don't exist yet.
Right.
There is no data science curriculum for middle school kids, and yet data science is probably going to be one of those key careers of the future. So I think we have some really cool solutions. And one of the groups that is working on this is the group who wrote the Next Generation Science Standards. So real quick overview of what the Next Generation Science Standards are. Go, Chris.
Right. So the Next Generation Science Standards, this group got together and said, you know what should students know for job preparedness and college preparedness out of high school? So this has standards that go all the way down into elementary school, and they build upon each other. So something that a student learns in 3rd grade is built upon in 4th grade, 6th grade, 10th grade, et cetera, on and on, with an idea of saying that not necessarily to learn anything specifically as far as science goes, but to learn a process, to learn a way of learning and engaging in science.
Yeah, exactly. So I like to, when I look at a standard, I like to break it down into its parts. And NGS is pretty easy to understand. The first part of a standard is the practices. The middle part is these cross-cutting concepts that are supposed to be parts that go between different disciplines. And then you've got the core science or engineering ideas that are part of the core ideas. So let's look at an actual standard. So that first part is what's highlighted. That is the practices section. So this is MS ETS 1-4, and notice that it says develop a model to generate data.
Ben, you're supposed to say yes, Chris.
Yeah, Christopher, yes.
Yes, thank you. I'm wondering, with this part of the NGSS standard, how do you develop a model?
That is a really good question.
Thank you.
So what is a model? Ta-da! I think we know what a model is.
Right.
Somebody who's really
ridiculously good looking.
Yeah.
Who's a merman, right?
Yes, of course. But of course we know what models are. There are all types of models, and we use models in education all the time. But NGSS is actually referring to a specific type of model. And really we're talking about systems. Everything that we deal with in the world is pretty much made up of systems. So I like to use this car example. A car is full of systems, and altogether it makes up a system. It helps you to get from one place to another. But it's made up of a steering system, you've got an electrical system, you've got heating and cooling systems. There's all kinds of different things. And so in order to experience a car, the best way is to actually get in a real car. But we use models to teach certain parts of a system. Now that comes with some limitations. So what are the limitations here with a car model?
Right, so like you said, the car 22 here from NASCAR, it has a very precise system to turn left a whole lot. And so, but what you're talking about here, the model, you can see on the right, that has a lot of the same stuff as the real one. It has the same paint job, it has 4 wheels, windows, and whatnot. But limitations are it doesn't have a combustion engine. It doesn't have a radio. It doesn't even have real chairs if you look on the inside there. It's just molded plastic to look like a chair. So there are things that we can learn about a real car with a model car. We just have to understand that it is not a real car. And that is part of the NGSS standards, is to say limitations are a part of modeling, and that needs to be acknowledged.
Right. Well, I wanted to mention, this modeling concept is really prevalent in NGSS. I had to do a count. I made a spreadsheet and I counted up all the different times. There's about 130 middle school and high school standards, and 21 of those, which is the most of any of them, say at the very beginning, develop a model. Mm-hmm. So I think there's something important here about understanding how models work, understanding their limitations, and what they can do, the similarities and limitations. So now I want to share with you a really cool technology. This is a CubeSat. And if you're not familiar with a CubeSat is an actual satellite that is floating around Earth. And it's teeny tiny. It is 10 centimeters cube. So to get a feel for how small that is, it's kind of hard to see that. But these satellites are they're just popping up all over the place, but they're still somewhat expensive. Now, they're not as expensive as the really big satellites.
Sure, you're talking about one that is the size of an SUV that costs, $40 million to $120 million just to build the satellite, not talking about how much it costs to get onto a rocket and all those other things.
Right. But what's exciting about CubeSats is it takes, it's more like about $300,000 to launch a 1U small CubeSat. Which is still pretty much out of the price range of most schools.
Yeah, Best Buy's not going to be carrying like their CubeSats launching kit anytime soon.
Right. It's still quite cheap compared to where it was, which is pretty exciting. That's why we're starting to see so many of these CubeSats pop up. But let's look at the model of a CubeSat now. So this is what we call our DemoSat. And it is a model of a CubeSat. So it's got some similarities and some limitations. So with a CubeSat, it is made up of systems. It's got a power system, it's got a computer, it's got its brain, it's got storage, and it's got its payload. So a CubeSat, a DemoSat, is very similar to that in that we've got a power system, you can see that there at the bottom. It's got an Arduino as its brain, and then we have our suite of sensors that is the payload. So this is a great way to be able to see what a CubeSat might look like by using this model.
Right. Well, and what we were talking about when we talked about the real car versus the toy car, was the fact that it is so far apart. There is only so many things about the car that you can learn from a toy car. But the differences between a actual CubeSat and a DemoSat, it's a lot closer. For example, it's a 1-to-1 scale model. So when you are holding a DemoSat, it is exactly the same as if you were holding a real CubeSat that was going to go up to the International Space Station and be launched out of their launcher. As far as we're concerned, for the sensor suite is an exact sensor suite that is going to go up with a set of Cube satellites. The Arduino is a real type of microcontroller that once you learn how to program, can program hundreds of different things, including actual real Cube satellites that go in space.
Very cool. So lots of similarities. There's a few limitations. Obviously, our DemoSat is not going to be ready to go into outer space. This is not something that we would actually launch. There's radiation hardening. There's all kinds of limitations. This is not going to be space-worthy, but we learned so much from all the similarities.
Right.
All right, so you're looking right now at a live view of our DemoSat. You can see kind of a little bit of scale by seeing how it compares to my hand. And you can see the different parts. Here at the top, we've got our suite of sensors. Chris, do you want to mention a couple of these sensors and what they do?
Sure. So you've got the infrared, which we'll be talking about a little bit later. It does temperature, luminosity, UV temperature, and the IMU, which is one of the coolest sensors in the world. This one, it looks like it's just one sensor because it's the same size as these other sensors, but it has many more things that it measures. It measures acceleration, so how fast you're shaking the CubeSat, or the DemoSat, your orientation, the roll. It has a magnetometer in there, so if you get a magnet close to it, it'll start detecting it. All sorts of ideas and stuff here that you can learn about the Earth. So in space, you would want to know about the Earth's magnetic field. This is the type of sensor that you would use for that. So knowing how to run this sensor on this DemoSat is exactly the same principles you would need to learn about measuring the Earth's actual magnetic field.
Spot on. There's one other thing here that's floating around. This is our wireless connection. This is just a little wireless XB radio connector. Gives about a mile line of sight connection. So what is that doing? Well, it's giving us access to the data that the sensors are providing. So what we want to show you next is our experiment platform. So this is a Chrome app, and it's pretty easy to download. You go to the Chrome Web Store and look up Ardusat, and you'll see this little app, and it connects an Arduino and sensors to be able to get live data.
So you can visualize the data.
You can visualize and check this out.
Yeah, the data is coming through. So now you can see, as an example, you can see the top row of sensors there are talking about the accelerometer. So as Ben manipulates the DemoSat, you can see readings going up and down, and you can see that the scale of the X and Y axis here are actually moving out because it's actually seeing more and more acceleration. So before, when it was zoomed in, the line there on the 0 looked like it was a lot of movement. But then once you got to these spikes of movement, you can see that it moved out to a number 5 and beyond a -5 over here. So what this does is, instead of just like if you were doing an egg drop experiment, you could actually use this to drop with the egg, and you would see how fast the egg was going when it hit the ground. And that's the power of and you can see here the power of the experiment platform. All of these sensors are available straight off of the DemoSat right now.
And I'd like to point out too that what we're looking at, all of that data, it's visualization, and I think it helps students to be able to understand what this data actually means. Seeing the charts really, I think, makes this real and helps you to understand it. But this is another form of a model. This is something that you could look at, and you could be able to, a student can develop this and be able to look and be able to say, here is the results of an experiment, and here is the evidence and the data that backs up what I just did.
Right, and then this is my hypothesis, this is what I've changed, and then getting the results of the changes in a way of either trying to perfect a solution or to prove or disprove a hypothesis.
Okay, so now what I want to do is let's switch and let's share a quick example of a fun little activity that we've developed. This is our zombie detector activity, and what it uses is 2 sensors. We're going to be using the luminosity and the infrared sensor. So Chris is going to do a little bit of manipulation, so we're not crowded with all of the different sensors and all the different data coming at us. Notice the drag and drop. We can resize pretty easy, so we've got easy access to look at these readings. All right, so first let's share some of our givens about zombies. So zombies are different than humans. One of the primary differences is they are dead. So we believe that a zombie will have a different heat signature than a regular human being.
Right.
So I think we're going to be able to detect whether or not somebody's a zombie.
Just happens to be that we have 2 sensors on here, one that detects temperature, one that detects luminosity. So I am guessing that we could program the Arduino here to know when somebody has put their hand over the DemoSat, and then using the light, the change in light, know that there's a hand over it, and then take a temperature reading with the IR temperature.
Right. So basically in this activity, we're looking at 2 data points, comparing them and analyzing them to be able to come up with an analysis of what that means.
Right. So as we've been sort of dragging out the explanation here, one of us is holding a cold beverage in our hand, and the other person is not. And so this is the idea behind the zombie detector. We actually have a set of rules this is a whole game that you can play while learning these standards and learning this principle. So we're demonstrating it for you now. So one of us is going to put their hand over the DemoSat and have a normal temperature, normal human temperature, and then one of us is actually holding a cold drink, and one of us is going to have an abnormal human temperature reading. So it's up to you to look at the charts here. And as a matter of fact, what I'm going to do is this button clears the data out so that we get a fresh set of lines here. You can see luminosity is like right around 500 right now, just a little bit above. and the infrared is right above 25 degrees Celsius. So, Ben, who do you want? Like rock, paper, scissors for who's going to go up front
No,
here?
I think you deserve to go first.
Carl.
Let's get.
Okay, so hand model going on here. So is that what we're talking about when we're talking about models?
Okay, so we notice a few things going on here. First thing, we instantly notice the luminosity went down. So the brightness that it is able to see went down. So that's kind of an indication that the test is happening right now.
Mm-hmm.
And then we can look over at the infrared temperature and we can say, okay, it looks like the temperature went up.
Mm-hmm.
Don't have to do a lot of data analysis to see that up.
The baseline was, like we said, right around 25, and now it looks like it's right around 35. So that's my reading for the experiment here, and now you can see that I've taken my hand away. We get back to our baseline of infrared and luminosity, so we're going to let that go just a little bit for a second here so that we can see the change here. So Ben,
All right, are you ready for my test?
yeah, go ahead.
What do you think is going to happen?
It's going to explode. No, it's actually going to show a difference here. Holy cow. So now what you can see here is the luminosity has gone down. So once again, we know that the experiment is happening. But right here is where your hand went over, and there's the down curve. We've got this down going right here. So we got down to pretty close to 20 degrees Celsius. So remember, my hand showed up at 32, and his is down at the 22. So now you guys are all going to have to excuse me because I'm going to go have to find a weapon and take care of the zombie menace here in the Ardusat studios.
Okay, one last really cool thing to show. So at this point, we could take a screenshot and be able to, turn in a screenshot of the data and be able to say, here is our evidence and proof, and this is our model of what happened during our experiment. We can also log the data and be able to get a CSV file so that we have the ability to open up all this data in Excel and really get our hands dirty with manipulating and understanding these data and having fun with it.
Right.
It's pretty easy to use. You basically are just starting and stopping. You choose the sensors that you want to gather data on, and you choose how frequently you want it to measure that data.
You get a file name?
Start and stop, and it's done. And you've got an archive of what you've collected as data.
Yep. And you can keep a list of the suspicious zombies in your class.
No doubt. That's an important part of science, right? All right. So at this point, we hope you know better what an NGSS model is and how the DemoSat is a model for engaging students in STEM activities. For more information on our products and services and to check out some of our additional lessons, please feel free to go to our website at ardusat.com. Follow us on Twitter at Ardusat. And thank you very much for watching.
See you next time.